All right, take out page 61. Page 61. Okay, we'll be starting electricity today, but there are a couple of loose ends left from ways we'd like to clarify. Like just one thing. I'll start electricity today. Right, so this is how stationary wave patterns are observed in water waves. So, right, so look at this. So you have this setup here. I'll be producing water waves here. And what's going to happen is that the water waves will form, as the water waves are falling here, they're interfering with each other. I don't know if you can notice it, but there's the interference pattern forming here, right? But you'll notice that it's like a line. And if I place like a graph for like a screen or something, the screen but essentially what's happening here is that these waterways are interfering, and at the center you have the region of what amplitude, maximum amplitude, because constructive interference. Tapor ei jagata is destructive interference. So in theory, if you were to keep an object here or be at that point, you wouldn't really feel any movement, waves power, okay? Because that's a destructive interference. This is a constructive interference, or that's a destructive interference, right? So water wave circles figure out. So let me show you how it looks like with light. So light here from and as light waves interfere, they'll go and hit the screen there. Light from the screen they so the screen what do I see on the screen? Dark and bright fringes. That's the interference pattern here. So it's dark fringe for which kind of interference? Destructive. Bright fringe for constructive. And remember the formula lambda equals to AX by D, right? Some wavelength comma X component, which means that the fringes must be further apart or closer. X fringe separation, fringe fringe must be gap vertically follow. So you wave right? Yeah, right? Let's see that happen or not. So for shorter wavelength, shorter wavelength, red or blue. Shorter wavelength, shorter wavelength, blue, right? So if I go to blue, so blue light will interfere right now, and as the light interferes, you'll definitely see that the fringes are much closer now. More fringes, basically. Do you see that they're closer? Okay, I'm ready to you see it's very wide spread out, right? So for the formula, they are mostly lambda equals to AX by D. Lambda change corresponds to your change in X value and whatnot. Okay, just keep in mind that dependent variable the key in lambda equals to AX by D equation, right? What will always be the dependent variable? fringe separation. Okay, কারণ lambda তো হচ্ছে তুমি দিচ্ছ, এটা তো চেঞ্জ করা যাবে না, মানে it wouldn't change. A তো slip separation, it's a mechanical physical change that can't happen. DO তো একটা screener distance, right? So এগুলা কিন্তু set করার পরে the outcome is going to be your x, and x is going to be the one that changes. Okay, so yeah, just keep that in mind. And that's the intensity graph that we saw. So yeah, waterways এখন আমাদের unfortunately multiple years আসছে that you have to draw and show it, and এই যে এটা draw করে show করতে হবে. Okay, so look at this. These are two waterways that are generated by two slits here, and you need to, in your exam, right, figure out কোথায় constructive হয়, কোথায় destructive হয়, and konta first maxima, konta second maxima, and whatnot, right? So it's too tricky, but once you can visualize the logic behind it, easy হয়ে যাবে. I'll show you কি করতে হয় এখানে. So I'll make it lighter so that's easier to notice. Right, so that's one of the waves there, and this is the other wave that's coming off, right? And these two waves will interfere. You need to figure out where would they interfere in what manner. So the bear correct easy ways, I'll show you. So তোমাদের exam জিজ্ঞেস করবে this point here, that point there, right? What kind of an interference would take place at that place? যে এখানে তুমি যদি হচ্ছে তোমার if you were at this place in the water, would you be jumping up and down with the highest amplitude? Would you have a medium average amplitude, or would you have no amplitude? No amplitude মানে destructive, double the amplitude মানে constructive, and an average amplitude মানে just interference, right? So এটা কি হবে এখানে কেমনে বের করব? So it's actually a straightforward process. I'll tell you কি করতে হয়. So what you need to do is count the wave fronts. Okay, so এখান থেকে এখানে কয়টা blue waves আসে আমাকে বলতে পারবা? How many blue waves came there? 4, right? Is it 1, 2, 3, 4 blue waves came there? So 4 blue waves showed up at that place. How many red waves came to this place? 2, right? Is it 1, 2 red waves? So if your 4 blue waves interfered with 2 red waves, right? What's the path difference? 2 lambda, right? 2 lambda path difference causes what kind of interference? Constructive, right? So ekhane and any place along this line, you'd find that key interference হচ্ছে constructive. Okay, now let me show you another point. তোমরা figure out করো কি হচ্ছে এখানে. Can you tell me এখানে at that point কি হবে? What's going to happen at that point? A constructive or destructive? Constructive, right? For a path difference of how much? Path difference of 3 lambda and 2 lambda. 3. Okay, so kemne how many waves are here? 1. A point of blue wave এর কথা বলতেছি, কয়টা blue wave reach করছে এখানে? Just 1, right? How many red waves are here? 1, 2, 3, 4. So 3 blue waves and 4 red waves, right? When they meet there, what's the path difference? 3. Okay, so এখানে তোমার maxima হবে, but এটা represents which maxima? Third maxima, right? তারপরে আমরা আরেকটা ট্রাই করি. Path difference is 3 lambda, right? So yeah, can you tell me what should this be? Constructive, right? What path difference? 2, right? কারণ হচ্ছে যে এখান থেকে 1, 2, 3, 4 আর blue wave হচ্ছে 1, 2, right? So what's the path difference? 2 lambda. So এটা যদি হচ্ছে third maxima হয়, right? That's my third maxima. এই লাইনটাতে কি হবে? Second maxima, right? So that's going to be my second maxima. And I think you can figure out the next one. Is ধরো a pointer. This one. What is that going to be? Yeah, because এখান থেকে কয়টা wave যাচ্ছে? Red 1, 2, 3, 4 আর blue কয়টা যাচ্ছে? 1, 2, 3. So what's the path difference? 1. So that's going to be your first maxima. And এই মাঝখান দিয়ে যেতে যাচ্ছে, like that line there, এটা কি হবে? 0. কেন আমি বলি যে এই পয়েন্টটা অবজার্ভ করো. How many waves, how many blue lines reach there? 1, 2, 3, 4. How many red lines reach there? 1, 2, 3, 4. So this would have provided my what maxima? Central maxima. বুঝছো জিনিসটা? আচ্ছা, এখন তোমাদের এক্সামে যেটা করবে ওরা এটাই দিবে, but they'll ask you find the second minima. So where is the second minima? Yeah, do you understand the logic? Because I know that my first maxima is there. I know my second maxima is there. Isn't the center between two maximas the minima? Remember? So minima ta ekhane dekha jay na, but minima ta amra infer korte pari by finding the what rather, the maximas. Ar duita maxima মাজখানে যে লোকেশনটা, this location is actually a minima. এটা কনফার্ম করে তোমাকে বুঝাতে পারবো আমি, দেখো কেমনে। So if I count my number of waves, right, এই যে এই পয়েন্টটাতে, right, how many red waves are there? 1 2 3 4 red waves. Do you agree? আচ্ছা, কিন্তু blue wave যদি চেক করো, 1 and what? Half, right? So what's the path difference going to be? Yeah, মানে a 0.5 multiple, and a 0.5 multiple would give you a what kind of interference? Destructive, right? So that's how a destructive interference forms along that line. Is that okay? I counted them from different. Blue from here, so 1.5. So you count the wave from their source, and the red one would be 1 2 3 4. Yeah, so just keep this diagram copy somewhere in the bottom. Their draw are very difficult, unfortunately, but I think I might have given a diagram. In the exam, they'll give you the diagram. You just need to label it. No, it's like right. Anyways, Tati Korna, I'll be starting electricity now. Question: how do we understand which source we have to put the minima in? Red and blue. How do we understand which source we have to put the minima in? Over here, you put it in the red light source. Why not the blue light source? Minima. Acha, it actually depends on the point. So, like for example, if I took this point, like the one on the bottom here, that would be how many waves from the blue source? 1, 2, and 3. 3 from the blue source, but 1.5 from the red source. So this would produce destructive interference as well. So it actually doesn't have to do with the colors. It's just counting the number of waves. And because it's symmetrical, right, whatever happens on top would replicate itself at the bottom as well. So, you know, the colors don't really matter. You just need to not count the number of waves that reach a particular point. Any point, you just count the number of waves that are there. What type of questions are asked? Some very challenging questions. So what they'll do is they'll give you this diagram, right? And they'll ask you obviously what I just did, and then they'll change things around. For example, they'll say that the water droplets, right, are not falling together. One falls and then there's a gap and then the other falls. So there's a phase difference between the source itself. And then what would happen there? So these kind of questions, like they'll make this complicated. That's why I felt like I should give you at least the base idea of what's going on here. Like, do we have to draw the way you give? No, so they'll put a point X and they'll say it's either constructive or destructive. I'll move on. Let's start with it, okay? It হচ্ছে question paper, you'll come across it. In fact, if I'm not wrong, review question ছিল last year ছিল এই বছরে দিন year. Yeah, past paper you'll have plenty of this. আচ্ছা সবাই একটু এদিকে, let me explain electricity. আমি তোমাদেরকে বলছিলাম electricity হচ্ছে is very similar to your O levels, okay? And I downplay the importance of electricity because it's actually very similar to O levels, but then again, students struggle with it. It's because not because it's difficult in A level, because you still have trouble with your O levels. Okay, that's the main reason. Acha, so এখানে যে জিনিসগুলো করাবো, some of the questions you'll recognize if you have good memory, because O levels is only for them. A level question for them because it's capable for an O level student to do them. Okay, so এখানে কোনগুলো নতুন থাকবে কি বলে রাখি, handful, like 3 new things. Okay, so if you read this, and if I told you this is an O-level syllabus, right, you'd agree. Current is the rate of flow of charge. Q equals to IT. It's just the fourth one is the new topic. I equals to NAQV. And it's very new. 2017 introduced course, okay? So that's something new. I'm just going to So I equals to NAQV is an equation. If you look at the power equations here, you have all seen them before. P equals to VI, I square R, V square by R. V equals to work done per coulomb charge, all those things, right? So এখানে কিছু নতুন নাই। তারপরে যে resistance V equals to IR, তারপর IV graphs মনে আছে তোমাদের, straight line for ohmic conductor, filament lamp, it's all same. And then this is supposed to be new, but then again এটা তোমাদের syllabus ছিল O levels, GC তে পুরোটাই ছিল, IGCSE তে you just had the relationship, right? So I'll still mark this as new, okay, because আর কিছু পাচ্ছি না। And আর যদি পরে যাই, so কোথায় difference টা, like, something has to be new, otherwise why would they have this here, right? ওইটা হচ্ছে comes here in this topic. That's the only new thing here. It's called the Kirchhoff law. So Kirchhoff laws are laws that you use to solve circuit, okay? And a laws will use for it, the circuit properties are derived. Now if I tell you the laws, right, you know them. Because Kirchhoff law number 1, current is same in series. Kirchhoff law number 2, right, voltage is shared in series. And then current is divided in parallel and voltage is same in parallel. Have you heard of them? Yes, you just never gave them a name, right? It's actually called Kirchhoff's current law and voltage law. That's it. Kirchhoff. তারপর হচ্ছে that's it. That's the electricity chapter. আচ্ছা মানে আর কিছু নাই এখানে, দেখো যে that's the end of it. So নতুন কিছু নাই, but then again, I can't just say all levels of Korean and move on because it never works that way. So I will go through everything, but with more focus on the new stuff, obviously. Okay, right, so let's start. I'll rush through the old stuff, so don't worry about the new one. You want to time the board. So understand that current, electric current is a flow of charge carrier. Understand that charge on charge carriers are quantized. Quantized জিনিসটা বুঝাচ্ছি জিনিসটা, it's very basic idea, and Q equals to IT. So let me give you a basic idea of what a circuit is, okay? এটা আমি হচ্ছে O levels, A levels, any levels হচ্ছে prefer করি we start off with this, so as students understand circuit actually কি করে. Because there's still a lot of confusion regarding what current is, what voltage is, current থাকলে can voltage impact থাকে. So a rundown on basic circuit idea. Okay, so what's an electrical circuit, and what are the terms that we know already? Okay, so this is the most simplest form of circuit possible out there. You have a power source and you have something that takes the power out, right? It's a resistor there. Now what happens is, in this power source, the one that we have here, a battery, right, chemical energy is used. So you have chemical energy used here. Some are chemical now used for it. The right term would be non-electrical. It could be any other form of power source, right? So non-electrical power source থেকে something happens inside this and it drives charges. Drives charges মানে হচ্ছে the electrons in the wire, they'll start to move around and they'll be pushed around. And as they're pushed by the terminals of the battery, this is plus and this is minus, right? These charges will start to move through the circuit. And the rate at which the charges move through the circuit is what we refer as what? Current. Current is how quickly your charges are moving. Okay, Now, the charge that's been transferred here, what they do is they carry energy as they move out of the battery. Why do they carry energy? So the logic behind this is, এটা তোমাদের সিলেবাসে ছিল বাদ দিয়ে দিয়েছে, so আমি একটু heads up দিয়ে রাখি. There's a chapter called electric fields. You'll find in your past paper plenty questions. 2019 বাদ দিছে ওটা, but 2022 তে মানে খুব recently. So you'll find till last past paper that chapter is there. It's called electric fields. দুইটা প্লেট থাকে, মাঝখানে একটা চার্জ থাকে, খুব পপুলার ছিল, but they got rid of it. It's now in A2, and they shifted it to A2. Okay, so we learned that if you have a positive terminal and if you have a negative terminal and if you have charge in between, right? A chargটা হচ্ছে ধরো হচ্ছে positively charged. Okay, can you tell me a chargটা কোন দিকে move করবে? Naturally downwards. You all agree, right? Acha, let's say I push the charge up and keep it here. A charge থেকে যেখানে রেখে দিলাম. Okay, and then what I do is I release the charge. So আমি charge থেকে কোনোভাবে উপরে রাখলাম and then I release it. What will the charge do? Move down. As the charge moves down, right, it gains energy. It starts to get what? Faster. What kind of energy does the charge gain? As K, because it's moving faster and faster, so it gains K. But according to law of conservation of energy, right, K can't just appear from nowhere. It must have come from something, right? Now, if I take a ball and I move the ball up and hold it here, and then I release it and the ball falls, that's very easy. GP to K, right? What's happening here? What's the energy that's been lost that gets converted to kinetic energy? The energy from the positive plate. What is that energy? That's the force, you're right. But what's the energy? What's the energy conversion here? What's the name? Yeah, it's called the electrostatic energy or electrical energy, which we eventually mold and give a name as the electromotive force. Remember the EMF, electromotive force? That's basically electrical energy here. The electrical energy has been lost, and what has been gained here? Ke, right? So what happens is, if you see these charges here, right? These charges are moving through your circuit, right? And they're carrying what with them? Electrical energy as they're moving through, right? And the amount of electrical energy they carry, each charge, the amount of energy carry for it has a name. What do we call that? The amount of energy the charges carry. Coulomb key. Coulomb is the unit for charge, right? Current key, how fast charges are moving. What's the amount of energy every coulomb charge carries? Voltage, okay? So the voltage that you know is actually what? The amount of charge that carries. Our current that you know is what? How fast the charge is moving, right? Now, I don't know if you can recall, do you remember the water bucket analogy? You take water from a water tank and you go and drop it somewhere else, right? Water bucket analogy, so water bucket analogy, you have a water tank, right? And you take the water from the water tank to another tank. Right? And you have some buckets here, five buckets. So what do? You put the bucket in the water, fill it up, carry and drop it, right? That bucket that takes the water in the circuit. Electrons, charges. Okay. So that's the bucket. Okay. Now I have 5 buckets. Is there a chance that suddenly I'll have 1 buckets? No, right? Will it be a possibility that buckets will disappear? No, right? So the number of buckets will remain what through a set up, right? So the number of charges that are moving through a circuit should keep the same. So if you start off with 10 electrons and everything goes around everywhere in the circuit, how many should come back all the time? 10 as well. Okay. Now, what is voltage? Yeah, the amount of water the bucket carries. Okay, so if you have very small amount of water in every bucket, right? But you're running around very fast, right? Does the other tank fill up? No, right? Energy beshi পাচ্ছে না, because you have a lot of fast movement, but buckets look সব কি খালি, right? That happens when you have what? A battery that has low voltage. So battery যখন low voltage থাকে, current কিন্তু flow হচ্ছে, but what are the charges lacking? Energy. Okay, so when voltage বাড়ায়, the individual charges will carry more energy, so you'll have more energy there. So tell me one thing before we wrap this up. I want to fill up my tank very quickly. Tell me 2 things I can do. Water analogy there. Yeah, so you know, fill up the buckets more. Can I have bigger buckets? No, that's something into, because let's say the size of a charge, which is an electron, is fixed. So I can't have bigger buckets. I can only fill them up with what? Maximum amount of water, right? So yeah, more water are more buckets করা যাবে না? Fill them up. No, that's coming out from a tap that's like fixed rate. Yeah, run faster. What is running around faster? Current. Okay, and if you remember the formula for power, কি ছিল? IV, current and voltage. এই দুইটা দিয়ে তুমি পাওয়ারটা বাড়াতে পারবা। Okay, you mentioned something. What was it? Yeah, so এই ট্যাপটা হচ্ছে analogy-তে is the resistance. Okay, so we don't really bring it in here. আমরা resistance অন্যভাবে শিখি. So let's say you're running around with your bucket, right? And there is a hurdle. ওই যে তোমার Olympic race hurdle থাকে না? There's a hurdle, right? And you're running around with the bucket. Do you think that as you jump over the hurdle, right, will you maintain your speed or will it be slower? Slower. So whenever you have a hurdle, what happens to the rate of flow? Decreases, right? But more interestingly, imagine in real life, you're running with a bucket and you jump over the hurdle, right? Do you think all the water will remain? Wouldn't some water be lost? So that's exactly what happens when current passes through a resistor. What is lost? Energy. Okay, so you know you have to sacrifice some as you go through. All right, anyways, these are like not even O-level stuff, these are grade 9 stuff, but I wanted to bring them so that you check the idea. Okay, so current and voltage and main difference is important. Current is how quickly you transfer your charges, voltage is how much energy they carry individually, right? So if I want my lamp to glow brighter, I can do either of them. I can use a very high voltage circuit, or I can use what current? More current, right? And you know, eventually I can do both if I want, but you know, either of them will do the same thing. So yeah, current is the rate of flow of charged particles. But here's something important, and now let's do the A-level stuff. Current is the rate of flow of charged particles. It's not the rate of flow of electrons. And then O-levels only allow করতো, but A-levels say it's not allowed. Current is the rate of flow of any charge, whether be it plus or minus. And we have seen evidence of this. Like for example, in electrolysis, there's this electrolyte. And when you have current there, what's flowing there? Ions. Which ion? Like copper sulfate, what ion would flow? Cu plus 2 and SO4 minus 2 দুইটাই flow করে. So current কিন্তু is the flow of what? Charges, any charge out there. আমরা যখন circuit consider করি, we make a assumption, I think you know that. What is it? That the charge that's flowing through a circuit is actually a what charge? Positive charge. মনে আছে তোমাদের? It's called the what current? Conventional current. Conventional current is the current that flows through a circuit, right? Convention consider করা হয় that positive charges are flowing through. So every circuit that we solve, electrical circuit, the current will flow from where to where? Plus to minus. Reality key though. Yeah, it's going the other way around. Still, এখনো A levels they will not, you know, want you to acknowledge it, but just keep that in mind. The current will দিকে flow করে. Okay, and that's about it for rate of flow. Clear rate of flow. So how do you find rate of something in anything? How do you find rate? Divide by time. So if I want to find the rate of flow of charge, or divide charge by what? Time. So that's the formula for what? Current. Q equals to IT, I equals to Q by T. Okay. একটা modification আসবে, modification that দিচ্ছে একটু পরে. It's actually I equals to not Q by T. It's del Q by del T. মানে the change in charge over change in time. Okay, because now you should know that just charge বললে তো it means a fixed amount, and time বললে তো একটা fixed amount. I need that amount of charge for that amount of time. And how do I incorporate that as a symbol? Del Q by del T. Okay, এটা maybe ASA you might feel redundant. A2 থেকে it becomes a very important factor. যখনই আমরা derivation করি, Q equals IT use করে কাজ করে না, dQ by dt লিখতে হয়. You know how differentiation works? ওরকম. Okay, right. Next বুঝাই তোমাদেরকে, charge on charge carriers are quantized. There's a whole chapter on this. Quantization. Have you done in chemistry quantization? Achha. So quantization te ki boli? Quantization basically tells you that charges can only be multiples of what number? Whole numbers. I'll explain. Okay. So let's say, though it a chemistry that to issue high, but whenever you write charges +1 +2, why don't you write +1.45? Like, you know, charge of copper or I don't know, lithium is +1.45. Possible? No, right? What is it? +1 or +2? I'm sure ratio করে কিছু একটা আসে, or 5/6 or something. But what I'm trying to say is that aren't the charges whole numbers? Why is it like that? So the idea is that whenever you have an object, right, and you want to charge it, You can only charge it by either adding or removing what from it? Charge electrons, right? So the thing is, can you remove partial electrons? No, right? So it has to be what number only? Ajay, what are you doing there? Phone table barabar. Right. So as charges are interacting with your object, right? Can you take out partial charges? No, right? So you can only take out charges in what manner? Whole numbers, right? So the idea is that charge is quantized. Quantized in physics, fixed numbers. So charges can only come in fixed numbers. You can't have what charges? Partial charges out there. I know it doesn't really make much difference here. Eventually, A2 থেকে আরেকটা topic আসছে ওরা যেটা করার সময় এরকম statement দিয়ে দেয় for A2. A2 তে we have an experiment to prove that charges can't be fractions. তখন হচ্ছে এইটা mention করতে হয়. Okay, that charges are quantized. Okay, I have not seen anything in AS yet about quantization, but the idea is that charges can only take what number? Whole number. Do you get my point? So 1 electron or 2 electron or 3 electron, no 1.5 electrons. So it means it can only be done in whole number multiples. Acha. And then you have the formula Q equals to IT. That is the del Q by del T hobe. Is that clear so far about current? I'll start with I equals to NAQ in a bit, but it a note target. Okay. So just copy the stuff that you need for your AS. All right, so a few important points that you need to know. Number one, হচ্ছে yeah, you can.
You say for specific one thing you can write the formula.
Like for a particular thing, you can't write the formula. I think you can write for all of them. But as we do, I'll probably figure it out. But so far, I remember you can write it for mostly everything. Right. So when I upload the notes on this, right, I'll also add your O-level notes here as reference because ওইটার উপরে build up করা হয়. But at the moment, I won't refer to that, but I'll provide that later on. Right. Try this question. It's A-level standard question. So it says wire has current decreased at a constant rate from 10 ampere to 4 ampere in 20 milliseconds. Find the amount of charge transferred. Try correct. 0.12. No.
Can it be negative?
Q equals to del IT. No, I equals to del Q by del T. 0.12. Yeah, sure. Milli stands for 10 to the power minus. Yeah, so that would give it. That's the catch. যে তোমার chapter গুলো O level sir, but questions গুলো after all A level 3 হবে. I mean, you don't expect O level questions again. Yeah. $300. Who got 300? Let's say no, you know 300 is. How do you get 300? Under no parameter we get 300 here. You can get 300 if you use the wrong formula. Q equals to I by T. If you use the wrong equation, you might get 300, I think. আর কোনো answer না তাহলে করে দেই। Okay, let's see what's going on here. Wire has current decreasing at constant rate from 10 ampere to 4 ampere. You need to figure out the amount of charge transferred. So আমি একটা analogy দিতে চাই এখানে, okay? তাহলে তোমাদের easier হবে. So তোমরা হচ্ছে math করছো কি 10 minus 4 করে, like the difference, right? আচ্ছা, okay. So the question is basically this. Let's say you have a pipe, right? Pipe থেকে water flow হচ্ছে, and the water is flowing at 10 meter per second, okay? And what you do is you turn down the tap from 10 to what? 4. So as you turn down the tap, পানি তো বের হতেই থাকবে, right? So within that process of going from 10 to 4, how much water was collected? That's basically the question. এখানে water জায়গায় কি collect করতেছি আমরা? Charge, right? বুঝছো জিনিসটা? So we are basically transferring charge, but we are transferring more and more charge or less and less charge, less and less charge. And within 20 milliseconds, the amount of charge that's coming out at the end is how much? 4, right? And what did it start with? 10. That's the rate, the rate at which it's happening. So এটা কেমনে করতে হয়? এটা করার জন্য there are two ways. আমি প্রথমে হচ্ছে তোমাদেরকে এই প্রসেসটাকে often use করার জন্য mindset change করতে যাচ্ছি, thought process change করতে যাচ্ছি. Look for graphs whenever possible. Look for graphs because graphs can make very complicated scenarios super easy. Okay, so if I plot a graph here for current versus time, and I know it takes practice to figure out the graph কাজ করবে, otherwise you might start drawing graphs for everything. So yeah, graphs are some places very useful, like here. So you have your initial current of how much? 10, right? And the current then goes down to how much? 4, right? And it says at a constant rate. I mean, does it go down randomly or straight line, right? And it comes and stops here. The time taken for this to be achieved is 20 milliseconds. Okay. Now, the question for you is what quantity, right, of this graph gives us a charge? Area in the graph, right? So I'm the area of the find the area of this shape here, I would have my answer, right? So area of 0.166. 0.116, right? Yeah, exactly. So area would be it's a medium. So area will be somewhat parallel, right? So that's again that's 4. So I think 1/4 height. Yeah. So 10 plus 4 divided by 2 into 2. So it can 20 milliseconds. So into 10 to the power minus 3. Got 0.14 coulomb as the answer. You guys took the difference in these two values, right? It doesn't really give us anything. Difference in these two values, course 10 minus 4, correct? But do you understand? We didn't need to find difference. We need to find something else. Like graph chart কেমনে করা যেত? Average. এই 10 থেকে যে 4 এ যাচ্ছে, constantly যখন কমে যাচ্ছে, average is the constant rate of flow. Because it's a straight line. So what's the average current here? Average current is 10 plus 4 divided by 2. How much is that? 7 ampere. Upper Q equals to IT 7 into 20 into 10 to the power minus 3, and 0.14 coulomb would have been the answer. That was the intended way. But why do you find average? There's no graph to draw. Okay, average term key করতেছে, it's basically mitigating the variation. So a line ta jodi draw kora hoy average ta, isn't it taking that extra area there and putting it there, right? So what does it eventually become? A constant rate of 7. That's what averaging does, right? But I can only use average because it's been mentioned that the thing happened in what rate? Constant rate. Non-uniform rate is possible, তখন things would be very different. Okay, দিবেও না most likely. You have to find the area under the graph manually. So a box count করে. Okay. So yeah, this is a question, but then again, I don't want to scare you. This is like the most difficult I've seen current. Okay, so things are easier than this. So are you clear about the basic introduction to current? So our next class হচ্ছে freshly হচ্ছে I equals NAQV দিয়ে start করব. That's the new thing. Did you talk to them? Yeah. I said that it's possible. So they didn't provide you any time in writing, right? Okay, I'll give them to let you. So what's happening is that at this stage, a lot of charges were flowing, but the amount of charge is slowly going down, right, every second. And it goes down really low to 4. So if I want to find charge, formalize current into time, and the current has to be a constant current. But unfortunately, the current is changing here. So how can I place a constant value if it continuously keeps changing? So what do we need to find here? Average. So once you find average here, that's 10 plus 4 divided by 2, 7 ampere, you get the same answer. Now let's say you don't understand the average concept. You just draw the graph. So it goes from 10 to 4, and it's a current versus time graph, which means that the area under the graph gives you the charge stored. So we just find the area.
Like if it was constant, তাহলে 6 নিতে পারতাম।
Yeah, the constant হতে তাহলে তুমি 6 না, তখন either 4 বা 10, মানে যেই ভ্যালুটা কনস্ট্যান্ট ছিল। বাট এখানে যেহেতু কোনটাই কনস্ট্যান্ট না, আমাদেরকে দুইটার মাঝখানের ভ্যালুটা নিতে হচ্ছে। That's all.